Thank you. Appreciate that. Okay. So I had several requests from people who wanted to look at Thevenin equivalent, and that's good because Thevenin equivalents are really important for everything that you do in electrical engineering. But they make it out in circuits 1, somehow it's more frightening than it needs to be. Because you rarely end up in one of the situations where you have to use any kind of fancy techniques. It is almost always easiest to do the technique of finding the Thevenin equivalent. Well, first, let me just ask y'all, what is a Thevenin equivalent? It's
what is seen through where you're looking at, like where you between points A and B.
right. So you have some point on the circuit where you are interested in, for some reason, maybe you're going to be putting a load, maybe there's something going on there. This is not the same circuit that's up there. You've just got some circuit with all kinds of stuff. Here we'll put a, whatever, capacitor. You don't care what it is, and so you're putting a load right here at AB, and you want to know what does the whole rest of the circuit look like from the point of view of AB. And you are hoping that what it looks like is, well, you can right now because this is, you don't have any other kinds of elements. You're going to be looking at it and figuring out, if I could replace all of this with one voltage and one resistance, what would it be? And as far as your load is concerned, the whole rest of the circuit, that's all it is. And you can see how that'd be really useful in electrical engineering if you're designing a piece to go right here. You don't care about the whole rest of the circuit, you just need to know what it is that piece is going to see. And I have found that for the most part, the easiest way to find the Thevenin equivalent is to find the voltage, so V Thevenin equals V open circuit. That is by definition. So that's not a technique, that is by definition. V Thevenin is the voltage across the open circuit where you would put the load. And then I find that usually the easiest way to find R Thevenin is usually with resistor simplification. The only tricky part with resistor simplification, as opposed to resistor simplification that you've done so far, is determining whether things are in series or parallel from the point of view of where you're finding the Thevenin equivalent, and then also what you do with sources. And you hope you don't have any dependent sources. If you have any dependent sources, it's only because it's circuits 1 and it's a test or a quiz that's testing you on that. You probably won't see it later on. So let's take a look at this first one here. And to find the Thevenin equivalent, the first thing we want to find is V open circuit. So V open circuit is the voltage across AB. So V Thevenin equals V open circuit equals VAB. Now, when I'm looking at the circuit as it is right now, to find V Thevenin, I have to keep these sources. So I have to keep the current source, I have to keep the voltage source. And notice how wherever book I got this from has V1 marked as the voltage across the 3 amp current source. VAB also equals V1 because for finding V open circuit, the 4 ohm resistor does not affect the voltage across AB because no current is flowing through it because it's open over here. And so for finding V open circuit, I need to find the voltage across this current source. And if I have the voltage across the current source, then that's in parallel with the voltage across AB. So if I find V1, I'm in good shape. So I'm going to do this. I always do this. So I want to use nodal analysis. Let me see what my solutions have. Yep, nodal analysis. So I'm going to mark this node right here as V1. So the voltage right there is the same as the voltage right here because there's no element in between. So this is everything up here is at V1. Everything up here is at V1. And I'll make this ground. How do y'all feel about nodal analysis equations? Are y'all pretty good with those? Was that a yes? Yeah. Why don't y'all see if you can write the one for V1, and I'll write it as well, but why don't y'all try to write it on your own and see how you do with it. And then after you've done it, you look up at the screen and see if you have the same thing.
So you wouldn't do the 4 ohm resistor because there's no current through it?
That's right. So did y'all get what I got?
160.
Oh, you already have the answer? Let's see. No, not need to multiply by 100.
Although this is where I always mess up.
Me too. Supposed to get 16. I'm not getting 16. What did I do wrong? Let's see. Multiply by 20, so 4V1 minus 100 plus V1, not 5V1. So that would be, that's interesting. That's 5V1 equals 160. Wait. Five V1 equals 160. V equals 32. That's what it's supposed to be. Yeah. V equals 32 volts. So V Thevenin is 32 volts. So now, to get R Thevenin, we're going to redraw our circuit, and we are going to short out any voltage sources, and we're going to make any current sources open circuits. So to find R Thevenin, you short voltage sources. So the 25 volt voltage source becomes a short. And current sources become open. And so that current source, I drew it as an open circuit, but you can see it doesn't do anything, so I can just leave it out altogether. And this is a 4 ohm resistor, and this is a 20 ohm resistor, and this is a 5 ohm resistor. Now, from the point of view of our load AB, Are the 5 ohm resistor and the 20 ohm resistor in series or parallel or neither? They are in parallel because it's the same as if we drew it like this. And then it's easy to see that they're in parallel. And the 4 ohm resistor is in series with these. Now you can't ignore the 4 ohm resistor when we're doing the Thevenin resistance because there's no current flowing through anything. So it doesn't matter if there's current flowing through it or not. We're just looking for the resistance. And so our Thevenin resistance is going to be 5 in parallel with 20 plus 4. So that's 5 times 20 over 5 plus 20 plus 4, or 100 over 25 plus 4, which should be 8 ohms, and it is actually 8 ohms. And so our Thevenin equivalent circuit looks like this. Now, most of the time you'll be using Thevenin equivalent. Sometimes you'll use Norton equivalent. I've just noticed that there are some engineers who really prefer Norton equivalent to Thevenin equivalent. There are some circuits that lend themselves nicely to finding the Norton equivalent. A lot of them, I just find the Thevenin and then change it to Norton. And so to change it to Norton, we know that the current source, you just use Ohm's law, V equals IR. And so 32 equals I times 8, or I would equal 4 amps. And so our Norton equivalent would be 4 amps and 8 ohms in parallel with the 4 amps. And that would give us our Norton equivalent if you had to find that. All right, any questions? Check Zoom. Did I do, oh, you made a sign-in sheet for me.
Mhm.
And all right. Yeah, I know autocorrect, it does crazy things. Okay, so I'm going to stop this recording and start a